Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we from Group 12 want to present about breadth first search algorithm and Bellman-Ford algorithm. So our group have 4 members, which is Ahmad Afiq Daniel bin Muhammad Kamal, Muhammad Alif Imran bin Muhammad Ruzaidi, which is myself, Muhammad Zairi Fazli bin Zakaria, and Muhammad Fikri bin Muhammad Asri. So first is project background. Breadth first search is an algorithm that abides to the idea of traveling through the nodes starting from the root node and then moving on to the neighboring nodes. After that, it will select the nearest nodes and explore the explored nodes. Basically, it traverses the tree by visiting the nearest node one by one before moving on to the next layer. Thus, the word breadth in the name itself refers to how it visits the nodes is like counting the number of leaves of a tree.
First of all, about project background, I will explain about Bellman-Ford algorithm. Okay, the Bellman-Ford algorithm, also known as Ford-Farquharson algorithm, it is based on the principle that is intuitively easy to understand. Each node A know the shortest path to node Z. To know to node Z. Then node A can be determined easily can be determined Then node A can be determined it is shortest path to Z by calculating the minimum cost. Each node connected to another node with a cost. Now, when the packet flow through a path, it results some cost to the network. To minimize the cost of network communication, Bellman-Ford algorithm is implemented and the packet flow to the path which costs less in the communication.
Next is what is measured. The breadth first search (BFS) makes it possible to calculate the shortest distances, which means measured in terms of number of arcs, between a selected node of a directed graph and all the other its nodes, and or build up the directed rooted tree with the distances equal to those in the original graph.
Net, what is measured? A version of Bellman-Ford is used in the distant vector routing protocol. This protocol decides how to route packet of the data on a network. The distance equation, which is the desired width in the network, is the number of routers a certain path must go through to reach its destination.
Okay, next I'm going to present about analysis. Okay, for breadth first search, okay, we assuming we have an undirected graph as above. Beginning from the vertex 0, the breadth first search algorithm commences by putting it in the visited list and putting all its adjacent vertices in the queue stack. We visit the element at the front of the queue, which is 1, and go to its adjacent node. As 0 has been visited, we will visit 2 instead. Vertex 2 has an unvisited adjacent vertex 4, which is at the front of the queue. So this is the figure. Only 4 remains in the queue since the only adjacent node of 3 is 0, which has already been visited. So we visit element 4. Since the queue is empty, we have completed the breadth first search of the graph.
Okay, hi. And then this is the Bellman-Ford algorithm. As you can see here, we got A, B, C, D, and E. Okay, and then this is what we are going to use, and this is the table. As you can see, it has 5 verticals and 10 edges in iteration 1. Only 6 edges that change, such as the edge of A3, AC, BD, BE, CE, and EB. Okay, we can refer here. Here we can see here. Okay, and then the other edge are not changed and update. The verticals A will be source that value is 0. So the vertical A will be source that value is 0. So you can see here, value is 0. Okay, the verticals A will visit vertical B, and the value for vertical B will be 6 because the 0 will be total with 6, the weight. The vertical A will visit vertical C, and the value for vertical C will be 7 because 0 will be total with 7, the weight. As you can see here, 0 will be total with the weight. Okay, the vertical B will visit vertical C, and then the value for vertical C will be not changed. The vertical B will visit vertical D, and the value for vertical D will be 2 because the 6 will be total with -4, the weight.
Okay, now I'm going to doing some demo about the breadth first search algorithm. Here we have the main class of the breadth first breadth first search algorithm, and here we have the subclass of the breadth first search algorithm. So when we run the algorithm, we will get the output like this. The breadth first search traversal of the graph is as follows, which is 0, 1, 2, and 3.
Okay, hi, I'm Fikri from this group, which I will show you how the BFA works. This is the BFA package that we use the codings. And first of all, we have to mix the SRC and dash and weight as a 0. And then we continue where we put the graph over here. We make it 0, 1, -1, 0, 2, 4. For the third one, we make it 1, 2, and 3. For the fourth one, we make it as 1, 3, and 2. Fifth, 1, 4, 2, and then 3, 2, 5. And 3, 1, 1, and 4, 3, 3. And then we have to put it with graph Bellman, graph comma 0, which is when we run the graph, you can see here, okay, this is the vertex distance from the source, which is 0 is 0, 1 is -1, 2 and 2 is still 2, 3 is -2, and 4 is 1. That's it from me. Thank you.
Okay, for the conclusion, for BFS, it's come with some great advantages to recommend it. One of the many applications of the BFS algorithm is to calculate the shortest path. It is also used in networking to find neighboring nodes, and also can be found in social networking sites, network broadcasting, and garbage collection. For BFA, it helps us to find shortest path from a vertex to all other vertices of a weighted graph.
Generally, BFF is much faster than BFA, as when involving smaller graph. But but to find uh to find from a single sources vertex, BFA is much faster. Both have similar complexity, but their different approach make it completely different. That's all from our group. Thanks for watching.